Assalamualaikum sir, it's me Asif Khan. My task is to design the very high frequency antenna, so that I choose log periodic dipole antenna. For designing the log periodic dipole antenna, I have to go to the CST Microwave Studio app. I'm just opening it, and then click no, and then go to the project template, and I have to select microwave RF and optical. Then I have to select the antennas, then I have to select the wire, then I have to select time domain and click next, then click next, and I have to give the minimum frequency 300 megahertz and maximum frequency will be 1800 megahertz. Then in the monitor I have to select all the things, that is E field, H field, far field, power flow and power loss, and click next and finish. Then it will actually take me to the screen that's actually shown, and now I have to unselect the bounding box, and then I have to go to the modeling and then select brick and click ESC. Then I have to give the name boom 1, and then I have to give the value of x minimum, that will be minus 0.25, x max will be 0.25, y minimum will be minus 0.25, and y max will be 0.25, z minimum will be 0.10, and z max will be 28.60. Then I have to select the material. For selecting the material, I have to go to the load material, then I have to select aluminum, then click load, and then click OK. Now I have to go to the components. In the components, I can see how many elements I can take. So in this design, I have to take 13 elements. So for taking the elements, I have to go to the cylindrical and click ESC, then give the name element 1, and orientation will be X, and outer radius will be 0.10. For the 13 elements, our outer radius will be the same, but the Z center and X max will be vary. For the element 1, Z center will be 0 and X max will be 1 point something. For reducing the time, I just write the all elements number in the Excel so that I can easily copy it. So for element 1, Z center will be 0 and X max will be 1 point something. I just copied it and then paste it and then click OK. It will show element 1 is taken in the screen. Then I have to take the element 2, so that I have to go to the cylindrical, then click ESC, then orientation will be X, and then give the name element 2. Outer radius will be 0.10 and Z center will be, and the X max will be vary. So Z center will be for element 2 is 0.6 something, and the X max will be minus 2 point something, then click OK. And again I have to go to the cylindrical, then click ESC, then orientation will be X, the element will be 3, outer radius will be 0.10, Z center and X max will be the different. So for element 3, Z center will be 1 point something, so that I can copy it and then paste it, and X max will be 2 point something, and I just copied it, then click OK. Again I have to go to the cylindrical, click ESC, orientation X, then element 4, outer radius will be 0.10, then Z center will be, for element 4, Z center will be 2.2 something. I just copied it and then paste it, and the X max will be minus 3 point something, sorry, minus 3 point something. I just copied it and then paste it for element 4. Now I have to take the element 5, then outer radius will be 0.10, then Z center and X max will be different. For element 5, Z center is 3.4 something and X max is 3.8 something. Sorry. Now I have to take element 6, sorry. Outer radius will be 0.10, Z center and X max will be different. For element 6, Z center is 4 point something and X max is minus 4 point something. Then click OK. Now I have to take element 7. Element 7 orientation will be X, outer radius will be 0.10, Z center and X max will be the different. Element 7 for element 7, X max will be 5 point something. I just copied it and then paste it. Sorry. X max is 5 point something. For now I have to take element 8. Orientation will be X, outer radius will be 0.10. For element 8, Z center is 8 point something and X max is minus 7 point something. Now I have to take element 9. Orientation will be X, outer radius will be 0.10, Z center element 9, Z center is 11 point something and the X max is minus 8 point something. Now I have to take element 10. Outer radius will be 0.10 and then Z center and the X max value. For element 10, Z center is 14 point something and X max is minus 10 point something. Now I have to take element 11. Orientation is X, outer radius is 0.10. Now I have to take element 12, sorry. Element 12 orientation will be X, outer radius will be 0.10 and the Z center and X max will be different. For element 12, Z center is 20 point something and X max is minus 16 point something. Now I have to take element 13. Click ESC. Element 13, orientation X, outer radius will be 0.10, then the center will be 28 point something and X max is 19 point something. Then click OK. So it's actually shown in the screen how many elements I just take. I take 13 elements. Now what I have to do is I have to click boom 1, then go to the boolean, then click element 1, then press enter. Then again go to boolean, then click element 2, press enter. Then again I have to do it for element 3, for element 4, for element 5, for element 6, for element 7, for element 8, for element 9, for element 10, for element 11, for element 12, for element 30. Now what I have to do is I have to copy the boom 1, then I have to paste it. Then I have to give the name boom 1 1. I have to give the name boom 2. Boom 2. Then I have to go to the transform and click mirror, and the mirror plane is 180. Then I have to click OK. Then again I have to go to transform, then translate. I have to give the y value is 0.56, and then click OK. Now I have to go to modeling. We are in the modeling, and I have to select brick, then click ESC. Then I have to give the name start1, and from the Excel I have to again select the values for start1. For start1, x max, x minimum will be minus 0.25. Y max is 0.25. X max, sorry. And y minimum is minus 0.25. Y max is 0.25. And Z minimum is 28.6. Max is 28.6 plus 3 point something, and then click OK. Then again I have to go to the brick, then ESC, then give the name start2. Again I have to give the all values for start2. X minimum will be minus 0.25, X max will be 0.25, Y minimum will be 0.31, Y max will be 0.81, Z minimum will be 28.6, and then Z max will be, sorry, Z max will be 28.60 plus 3 point something. Again I have to go to the brick, then click ESC, then I have to take the start 3's values for start 3. X minimum will be minus 0.25, X max will be 0.25, y minimum is minus 0.25, y max is 0.81. Then I have to copy the Z minimum value and then copy the Z maximum value. Then I have to click OK. Then what I have to do is select start 1, then go to the boolean, then start 2 and press enter. Then select start 1, then go to the boolean, then start 3, press enter. Now what I have to do is I have to go to the simulation and give the frequencies value that is also in here, then click OK. Then I have to go to the simulation. Where in the simulation, then I have to go to the peak points, click peak phase center, and then double click on the first one. Then again go to the peak point, then peak phase center, then double click on the second one. Sorry. Again I have to go to the peak point, peak phase center. Yes. Now what I have to do is I have to go to the discrete port and give the values, also apply, then OK. Then I have to go to the field monitor, then select far field and give the values. For far field 300, apply. Then for far field give the 400 value, apply. Then 500, 600, 700, 800, 900, 12, 1012. Okay, now I have to go to the E field and give the values 300, apply, then give the value 400, 500, and 600, 700, 800, then I have to give the values 1000 and 1200, then apply, and then I have to go to the H field and give the value 300, click no, Then I have to go to the power flow and again give the same values for the power flow. 300, 400, 500, 600, 700, 800, then 900, then 1012. Apply. Then I have to go to the electric energy density and give the value 300. Apply. 400. Apply. 500. Apply. Then 600. Apply. 700. 800. 900. Then the last value is 1200. Click apply and then click OK. Now what I do is, for starting the simulation, I have to go to the setup solver C T and give the value -30.0 dB. Click normalize and then apply and then start. So it will take time to give me the result of the simulation. So that's my design. So it will take time, so that I just pause the video. So after successfully run the simulation, here are the simulation results. So this is the time signal and this is the S parameter results, and this is the reference impedance, and this is the S parameter balance, and this is the power, this is the loss in metals, this is power accepted, and here is the field energy, here's the discrete port current, and here's the result of discrete port impedance, and in here this is the result of discrete port voltage. Also we can see the efficiency, radiation efficiency, and in here total efficiency, and in here the result of voltage standing wave ratio. This is the result for electric field for 300, and this is for the H field, and this is the surface current result, and this is the power flow result for 300 frequency, and this is the energy density result, and in here this is the far field result, which is so that's my video. Thank you.